This panel lets me modify the fingerings I wrote on a fretboard to find inversions, alternative fingerings or subsequent shapes. The panel contains several functions, laid out kinda like a compass, that lets me manipulate the content of the fretboard. Let's see it in action. Let's start with a simple A minor triad and test the various functions. For starters, I can transpose the content by 12 frets. This already shows us another little feature that notifies if the content of the fretboard has been moved outside the visible portion of the diagram. I can quickly add more frets from the middle section. So, the top two arrows will transpose the fingering by an octave, remaining on the same strings set. The two arrows in the middle, pointing up and down, instead move the notes vertically on the fretboard, changing the string set. The fingering move up and down the strings and adapt so that they always are the same notes, possibly on a different octave. In this case, you see that the fingering is changing strings, and it is also moving to the side by a few frets, and between the strings B and G it changes shape, because the strings are tuned a third apart instead of a fourth. Basically, it always preserves the note, in this case A, C and E, while it moves around the possible fingerings. The side arrows in the middle do a similar thing. They move the fingerings left and right, playing the exact same notes on the same octave, but finding options that are more toward the end or the beginning of the fretboard. This is not always possible, so sometimes this function can yield no results, unless the string set is changed as well using the other function, so to allow more room for the lateral movement, like in this case. Moving on, the result of the function of the bottom side arrows will depend on what you wrote. If it is an arpeggio, it will be the next inversion. If it is a scale, like in this case a pentatonic scale, it will be the next shape of the scale. Or if I write a chord, when I click on next shape, I will get the next inversion of the chord, like with this A minor chord. The last two buttons on the bottom let me automate this process and automatically create a diagram that contains all the inversions on separate layers. I can choose if I want them to be on the same strings or if I want them to be as close to each other as possible by changing string set. Let's try the first option. Here, while staying always on the same 4 strings but changing the order of the notes, I have 4 different inversions of my chord on 4 different layers, so that I can easily visualize them individually. Labels are applied automatically and indicate on which layer each shape is located. Now I will repeat the process on another fretboard using the other option, a round frets area, that stays as close as possible to the original section of the neck. The application will do a very similar job, but will move the chords as close as possible to each other, while keeping the exact same notes and voicing as the other option. It just changes the string set. These functions can be very useful to find close alternatives to chords without moving too far away from the position of the original chord. Even if I'm using a very simple chord in this example, this function will work with any absurd voicing you can think. Every time it will find all the alternatives. It works also using scales, patterns or extended arpeggios. In each case, it will generate all the options on all the sets of strings and positions. Let's pay attention to the note names to see more clearly what's happening to this fingering. We see that the notes are always the same ones, A, B, C, D, E, F, G, in the various possible fingerings. I can change the fingering position to the left or to the right, or I can generate the next shape of this scale. This means that if this is an A minor scale, the next one will be a B Locrian, then a C major, D Dorian, E Phrygian, F Lydian, G Mixolydian, and then again an A Aeolian. This is the same as thinking of them as inversions. So, to sum it up, if we write a chord, the function will rotate the inversions of the chord. If we write a scale, it will move between the various shapes of the scale, generating each time a musical content that is equivalent from a melodic and harmonic point of view, but with different voicings and fingerings. If, for instance, we write a pentatonic scale in the first shape, the algorithm will generate all the shapes of the pentatonic scale. Obviously, I can use less common fingerings as generative material, or alter and modify them in any way, and the application each time will calculate all the various inversions and fingerings. After using this function, I can always rearrange and edit the results.